All right, dude, we are live. What's up, guys? This is Dem Keys, and we just started out the stream with the fucking voice crack. Holy shit. What's up, guys? This is Dem Keys, and today we are going to be looking into a Rust based game development framework, or I should say, actually, a Rust based game engine called Fyrox. I actually completely forgot about this engine. Um, I forgot that this was one of the options because a while back I had looked into um, game dev stuff for Rust back when I was trying to look into the various crates and frameworks and stuff that are available for various different subjects in Rust. So I was looking for audio stuff, I was looking for data science stuff, I was looking into machine learning and deep learning stuff. And out of curiosity, I decided to check if like what was the landscape like for game dev. And I did come across a couple of libraries, and they each served different purposes, right? Um, some of them were actual game dev libraries, actual game dev crates, and some of them were more to simplify the process of being able to display something on screen. So, um, something similar to Nano, essentially. So, rather, I should say some of them were full fledged game dev frameworks and game engines, but some of them were more categorized under creative tools. So, I found a bunch of different crates and stuff. I believe Kiss 3D was one of them, if I remember right. Yeah, I think Kiss is Rust based. Yeah, yeah. Kiss was one of them, and in terms of game development, there was Bevy, and then there was also Fyrox. I looked at Fyrox, and I cannot remember exactly what the reason was back then, why I decided not to go deeper into it. To be fair, I hadn't done nearly enough research on the architecture that you're going to be following when you are coding the logic for these games. At the time, I didn't really know too much about um, how you would be going about doing game development in Rust, because I was coming from a Unity background. And there's a lot of stuff provided to you out of the box, a Unity slash Godot background, but like I have much more experience in Unity. I'm like very well versed in Unity at this point. So like I haven't touched the game engine in like I haven't done anything proper with the game engine in probably like a good 6+ months. And the last time I opened up the game engine might have been just to open up something or check something or whatever. That might have been like a couple months ago. And even that, I wasn't really doing too much serious work with that. So I haven't, even though I haven't done anything serious with Unity for the past couple of months or close to a year, um, I can still open up Unity and I'll know what I'm doing, if that makes sense. So like that's how experienced I am in Unity. That's how well versed I am in Unity at this point. That's how comfortable I am in Unity. And it's kind of the same thing with C Sharp. I've been doing C Sharp for a decade, more than a decade actually. And the first few years were just doing general uh, application development. And eventually I did a couple of serious projects for clients. That was, again, still general purpose application development. And then a couple of years later, I discovered Unity. And further from that point, the majority of my C Sharp work was all aimed towards game development. Right. Okay. Enough about my history. So I wasn't really sure exactly what I'm supposed to be looking for, what differences I'm supposed to be looking for. I wasn't even sure if I was looking for differences. I was mainly just exploring the landscape, trying to figure out, hey, what are my choices and how do these choices differ from each other? Now, I cannot remember exactly why I decided not to go with Fyrox at the time. I'm wondering if it's because at the time I was really jazzed up for my terminal based workflow. So I was like, okay, you know what? Bevy makes it so you can do everything from code itself. So that kind of seemed very appealing to me, and maybe that's why I decided to go with Bevy at the time. I opened up the Fyrox website and I saw there's an editor, and I was like, okay, for now, I wanna stick with just doing terminal stuff. And then I guess later on, I just kind of forgot about Fyrox. I wish I would have remembered Fyrox because I am okay with doing GUI stuff to a certain extent. I would still very much prefer for the majority of my workflow to be terminal based, but I am okay with doing GUI stuff to a certain extent, and uh, game development is definitely one of those things that are one of those situations where I feel like having an editor, it definitely helps. It helps you do a lot of higher level stuff, which you would otherwise be doing through code. Like all of that would have to be done through code, and not that it's not that it would be really hard to do. It's just that it would be time consuming, and it would be an unnecessary amount of effort that you could have or I could have put towards the actual game development. Anyways, um, here's what happened yesterday. Okay, I'll get to Fyrox in a second, but here's what happened yesterday. Yesterday, after the stream. So during the stream, I was talking about how I think I'm gonna explore both Nano and Bevy because Nano is moving towards uh, turning Nano from a standalone library of its own uh, towards being a Bevy plugin. So Nano is working towards making it so their library is essentially running on top of Bevy because Bevy already has a lot of the tech that Nano runs on, and kind of letting Nano sit on top of Bevy, it's gonna remove a significant amount of load from the devs because there's a bunch of tech that Bevy already has that Nano would then be able to use, and all of that tech's um, the load of maintaining that tech would not be on the devs anymore. And there's going to be other let's say niceties that come along with this move that they're making. Um, so that's great. That's great. But I was like kind of trying to decide, hey, do I want to spend time learning Nano or Bevy or both? Like, what direction am I going with here? Because Bevy is majority of the stuff in Bevy is ECS based, and well, Nano has a very different way of doing things. Nano is a creative coding framework, so it gives you the creative freedom to just draw whatever you want wherever you want. Like you have a lot of creative freedom when it comes to graphics, and there's a lot of creative coding scenarios where that freedom means something. That freedom is necessary. Just being able to draw whatever you want in whatever way you want, it means something. You don't want to be uh, you don't want to be tied down by an ECS architecture. ECS is great in its own right. It helps in a lot of game dev situations. It's not suitable for all game dev situations, but it can definitely help with a lot of game dev situations because it's less of an object oriented approach and more of a data based approach, or data oriented approach. Let's say. Where was I going with this? I forgot what I was saying. So, anyways, okay. After yesterday's stream, wait, give me a second here, man. I had a time. I had I had, holy shit, I had a time. I'm not gonna say a good time. I had a time. After yesterday's stream, because at the end of yesterday's stream, I decided to go with um go with learning both Nano and Bevy, and I was still kind of like I was still kind of like iffy about it. I wasn't sure how I wanted to go about this whole thing. So I decided to have a conversation with Gemini about it. I'm just gonna load that conversation up real quick. Um, what was it? Scratch stuff, empty directory. Let's open up Gemini here. So I was like, okay, fine. We're gonna learn both Nano and Bevy. At the very least, I want to learn the basics of Bevy first. I'm anyways planning on learning Nano, so that's fine. Oh God, chill out, chill out, chill out. I unlocked my phone and TikTok was open, and then whatever video was playing, the sound from that came. I hope that doesn't get flagged when I upload this VOD to YouTube because holy shit, that must have been like 1 second only. I hope that doesn't get flagged. But anyways, um, what was I trying to do? I needed to open up my Twitch stream and have my chat open so that I can see the chat. Oh, chill out. Okay, so um, I have opened up this thing. Chat, resume. What are we looking at? How Nano runs, Rust game dev architectures. Yeah, okay. So I was having a conversation with Gemini about this because I was like, okay, I we have discussed this before, and Gemini had suggested that, hey, if you're going to be using Nano, um, you do want to try out an ECS based approach. And the good news is that Bevy, it's modular, so a bunch of the functionality in it is also available as a separate crate. Dude, we need to take a second to like appreciate the software design that goes into making a modular framework to where not only can you control the functionality or control the features of the framework that you're currently the framework that all of those modules belong to, but you can also use those individual modules in separate projects to kind of gain the functionality from those specific modules. So you don't have to install the entirety of Bevy along with Nano. You could just install that one Bevy ECS crate because system, the ECS crate is implemented as a separate crate, separate from Bevy itself. Meaning you can actually use that crate to implement an entity component system in any other application as well. So initially, Gemini had suggested that um, you could you could do a simple game loop method as well, because like you don't absolutely need like especially if it's like a really simple game or if it's a very simple prototype, because like not everything is a big massive complex game. Not everything that you build that's game dev related is necessarily meant to even be a full production ready game. Sometimes it's just like fun prototypes and stuff, right? So ECS isn't always the answer there. There are much simpler methods that you could implement that work well with the creative freedom that Nano offers you. Where was I going with this? Yeah. Um, However, you will at some point start to see issues with the other architecture, and you'll see how Bevy ECS kind of solves this issue. Not only that, it solves another issue. Apparently, these are Gemini's words, so like I'm not entirely sure. I'm probably going to end up testing it at some point in the future. But what Gemini said was, there's another issue that you might run into, which is something common in game development. Not the issue is not common. It's the thing that you're trying to implement that is common in game development. It's this thing where you have these objects, right? And you probably want multiple things to be able to affect an object or an entity of some sort. The issue is in Rust, you have memory safety through something called the borrow checker. And this borrow checker has a set of rules that it enforces at all times. So one of the rules, for example, is um, at at any given time, if a variable is being borrowed, you can only have one mutable borrow, and you can have any number of immutable borrows. Immutable borrows are basically just reading, and mutable borrow means that you're borrowing this value with the possibility in mind that you might actually change this value. That's why you're mutably borrowing it. And trying to follow that while also setting up a game dev architecture, you will sometimes have friction between your architecture and the borrow checker itself. And apparently, Bevy ECS had found like a robust solution for that. The way that Bevy ECS was designed, it kind of avoids those problems. So that's another benefit that you get. Where was I going with this? Yeah, okay. So I was having a conversation with Gemini. I was saying that, hey, look, um, I want to do this. Actually, okay, I'm talking about an older conversation as well. Gemini was telling me that you might need to eventually, incorporate ECS. You can go with like a much simpler approach as well, but eventually you might need to incorporate ECS. Depends on you know how you go about your development and what kind of game it is and stuff like that. All right. Now, um, yesterday I was having a conversation with Gemini. I had asked the question here, which was, let me. Okay, for some reason the question didn't get, like the prompt that I'd given, it didn't get recorded. It's only Gemini's responses that got recorded. I'm gonna try and remember. Yeah, I think my question was that, hey, look, I've decided to do game development in Nano. I'm aware that Bevy exists, but I want to use Nano. And in the past, you have suggested that Bevy, in the past you have suggested adding ECS functionality to Nano, and that's possible through Bevy ECS. However, I was wondering, what if I didn't want to take that approach? What if I didn't want to use ECS? What are my other options, and how would those approaches work and stuff like that? Actually, you know what? Let me just a second. Okay, yeah, let me export this. It's called Gemini Explains. Um, Rust Game Dev Architectures. These are some big ass names that I come up with, but like, who cares? I'm gonna delete the file after reading it, anyways. Okay, now let's open up a new tab. In the new tab, once it does open, scratch stuff, um, empty directory. Okay, then here I want to open up Gemini Explains Game Dev Architecture. Okay. And I'm also going to need to open up Gemini, not Gemini, NeoVim in my other machine. Um, okay. So yank all the way to the bottom, and let's just confirm that this works. Yeah, this works. Okay. Close that. Come here. I need to go to an empty directory. I have Tokyo open here for some reason. I have this open. Okay, we can use this. cd empty directory. Actually, I don't need to put this into empty directory. Yeah, this can just go into Gemini explains Rust game dev architectures.md. Let that open up. Now give me a second here just to be sure. Okay, great. So this is done. We can save this and then open this up in, man, I love this render markdown plugin that's currently active. Because of this, I can do stuff like go on a specific line, which would otherwise be rendered. You notice the bullet points. It would otherwise be rendered. However, if once I hover over that line, it shows the actual raw text that makes up that markdown line. So you can see stuff like there's a bullet point, there's highlighted text in there. On the next line, you have stuff in like italics. You have um, more stuff that's highlighted as well. Yeah. Anyways, let's save this, close, and then open this up in Frogmouth. Oh shit. Um, I didn't realize that this. Okay, right. Here's my prompt. Um, I said, help me out here. So I'm learning Nano. I want to use it for creative coding, like like a live VFX app, a VTuber app, maybe some random graphics for my stream, and so on. One other thing I want to use it for is game dev. I'm coming from a Unity background. You have mentioned before that I would be better off using the Bevy ECS crate along with Nano. If I do want to use Nano, and I really want to use Nano, I've considered that, and maybe I might use Bevy ECS to apply the ECS architecture in my Nano project. What I'm wondering is, let's say I didn't want to do that. What options do I have um, for doing game dev in Nano? Obviously, this would depend on a lot of factors, but I want to learn the but I want to get a general idea. Like, how would I go about doing game dev things in this framework that's built to give you the freedom of creative coding and doesn't restrict you to a specific architecture? Also, if I did want to apply another architecture, what are my options? And are there crates for them as well? Like there's Bevy ECS for ECS. So that was my prompt. And then here was the response. Of course, it's a great question coming from a framework like Unity, which has a very established quote unquote Unity way of doing things. The freedom of a creative coding framework like Nano can be both liberating and a bit daunting for structuring a larger project like a game. You're right that ECS like Bevy EC, you're right that ECS like Bevy ECS is a powerful and popular choice, but it's far from the only one. Let's break down the other options. Game dev and Nano. Game dev in Nano without a formal architecture. For simple games, you don't necessarily need a complex named architecture. You can build you can build a lot just by optimizing your code logically within Nano's core model, update, event, and view functions. This is often called a classic game loop architecture. Here's what it looks like in practice. The model struct is your world. Your main model struct holds all the game state. Instead of a world of entities and components, you'd have collections of concrete types. All right. Player, enemy, bullet, model. Okay, there's some code there that, how do we, I forgot how you navigate in this. Like, do I need to click on this? Okay, anyways, it's a small amount of code. It doesn't matter. Okay, then Um, just a second. Right. Then you have update in your games, in your game logic. In what game? No, update is your game logic engine. The update function is where everything happens. You'd have different sections for different parts of your game logic. Okay. Move all the bullets, move all enemies. Okay. All right. And then there's collision detection as well. Right. This approach is straightforward and easy to understand and perfectly fine for many games, especially jam-sized games. Gemini probably means game jam games. Wait, did something happen? Oh, wait. Okay. Yeah, yeah. Um, yeah, jam-sized projects. Its main drawback is that as your game gets more complex, example enemies with different behaviors, complex collision rules, etc., the update function can become very large and hard to manage. Then, alternative architectures. If the simple game loop feels too unstructured, you can adopt other well-known software architecture patterns, like object-oriented programming with traits. While Rust isn't a traditional OOP language like C Sharp, you can achieve a similar and very powerful structure using structs and traits. You define a common interface, a trait, for all game objects, and then store them as a collection of things that adhere to that interface. Concept: define a game object trait that dictates the essential behaviors of anything in your game, like update and draw. Okay? Right. Then in update, we iterate over all of those objects. Okay. All right. So this becomes OOP, an OOP-like architecture. You don't need a crate for this. It's a pattern you can implement directly and is very idiomatic in Rust. I should actually try to implement this. I'm very interested in seeing how you would go about doing something like this. I want to see how far I can get with the game object architecture or with the OOP architecture, and what are the pros and cons of it. Yeah, yeah, that should be kind of fun. Maybe I could try implementing a very simple prototype using this architecture. You don't need a crate for this. It's a pattern you can implement directly and is very idiomatic in Rust. Then next pattern is state machine. A state machine is dude, okay, this is something I'm also interested in because I have no idea about how this architecture works. I've never even used this kind of architecture. Like I might have used programs that implement this architecture, but um I've never directly used this architecture. Like I haven't implemented this kind of architecture myself or had to use this kind of architecture in code. It's also possible that I did use this kind of architecture in code, but I just didn't realize that I was doing that. But anyways, okay. A state machine is no, a state machine is excellent for managing the overall flow and state of your application. Example, menu, playing, paused, game over. You can combine this with any other architecture. For example, your playing state could contain a world full of game object traits. Your playing state could contain a world full of game object traits or an ECS world. Okay, concept. Your model holds an enum representing the current game state. The update, view, and event functions all delegate to the same state, to the current state. Now, I didn't get that. Your model holds an enum representing the current game state. Your model holds an enum representing the current game state. Okay. Your model holds, for some reason, I'm just blanking as I'm reading this. Your model holds an enum representing the current game state. Okay. The update, view, and event functions all delegate to the current state. What does that mean? So okay, we have an enum. Within the enum, we have main menu, playing, and paused. Main menu takes in a main menu state. So I'm guessing those are also, oh, those are just names. They don't have specific types. All right, so we are able to pass in state. Where is state defined? Oh, we are not passing in state there. State is whatever, hold on, game state, main menu, state. What is populating this? Okay, so we have model. Model is that, and then model has current state. So model dot current state, which is game state. We can set the state from something, right? The model would also need to be passed around, right? I'm noticing these are all borrows. Actually, not update. Update is not a borrow, though. Update itself is consuming, because this is the update function. So update is consuming the update. I'm assuming it's a struct. Okay. Crates. While you can build this yourself with an enum, several crates can help manage state transitions and logic more formally. Bevy state, which is part of the Bevy ecosystem, um, Bevy state is part of the words Bevy state, part of the Bevy ecosystem, but it's a very well designed generic state machine that you could potentially use standalone. It's built on top of an ECS, so it might pull in more than you want. Wait, it's built on top of an ECS, so it might pull in more than you want, but it's worth looking at the concepts. Then you have State Machine, a popular and more lightweight crate for creating state machines in a very clear, declarative way. Okay, let me look up, because I do remember seeing a crate called State Machine. Um, I don't remember if it's actively in development. However, I do also need to see um, if it's even necessary for it to continue being actively developed. Like if the thing is already feature complete, then you know they're not gonna keep adding stuff to it. State machines and so state machines. There's something called static. Static. I think it's supposed to be. I think they're trying to say static, but like they added a G. Um, Hierarchical state machine for designing. For designing event-driven systems. Okay, okay. This is currently in development. This is currently in development. Hierarchical state machines for designing event-driven systems. Hierarchical state machines, state local storage compatible with no STD. State machines are defined in ROM and no heap memory allocations. Okay. Macros for reducing boilerplate and support for generics, support for async actions and handlers. All right. Okay. Cool. So this is something that we could look into. Give me a second. I can bring it up here. Just a moment. What am I looking for? Rust static. Let me just bring that up. And let me load the repo. Okay, so while this is loading, I guess I can talk about, I can continue with the well, okay. Anyways, this is loaded now. Um, yeah, here it is. So this is static. Static in action. A simple blinky state machine. Oh, you know what? The fact that they have, and I'm glad that they did the blinky thing because you know what? You know what's interesting? There are so many different concepts in programming and in the Rust ecosystem itself. So many different, I should say, concepts and constructs as well that you don't always think about applying them to various other situations. Like for example, it would have never occurred to me to try and apply a state machine kind of thing because I'm looking at it from a game dev point of view, right? I'm explicitly looking at this for game dev purposes, right? But then it would never occur to me that, oh, hey, this crate is no STD compatible, meaning I could technically also use this while doing embedded programming, embedded Rust coding for the ESP32. So I could have state machine based stuff going on in a microcontroller. Now, how that's going to benefit me, I'm going to have to find that out after I've had a chance to explore um, state machines more. I am curious about this. Concepts, states. States are defined by writing methods inside the impl block and adding the state attribute to them. When an event is submitted to the state machine, the method associated with the current state will be called to process it. When an event is submitted to the state machine, okay, by default, this event is mapped to the event argument of the method. Okay, super states. Oh, wait. Every state must return an outcome. An outcome can be one of three things: handled, transition, or super. Handled means the event has been handled. Transition means it's transitioning to another state. That's interesting. Um, I'm wondering if Unity's, what was it called? Unity's like animation system. No, no, no. What was that called? Mechanim. That's what it was called. Mechanim. It was their state machine based system where you had like a node graph. You could set up the states as different nodes, and then you could easily transition between them. And you could also control like various properties, like how much how you would want to blend between the two and how long the transition would be, what would happen during the transition. There was a whole lot of customizability that you could do. Okay, then there's handle, there's transition, and then there's super. Defer the event to the parent super state. Super states allow you to create a hierarchy of states. States can defer um, an event to their super states by returning the super outcome. All right. Super states can themselves also have super states. Oh, okay. That's where the hierarchy comes in. Actions. Actions run when entering or leaving states during a transition. Then shared storage. If a type on which your state machine is implemented has many fields, you can access them inside all states, super states, and or actions. Or alternatively, set LED inside the entry action. Dude, this is like this is what I'm talking about. Like all of these higher level concepts, all of these systems, all of these, I guess I guess these count as constructs, like these different systems that have been designed, these different architectures that have been designed. You have stuff like the actor model. You have the actor model. You have this state machine based thing. You have an entity component system. There's also the very famous concept of async programming, which in Rust, fortunately, they've designed the system so well that they're able to do both async and multi-threading at the same time. Holy shit, dude. I'm so glad that I'm exploring all of these different fields because I feel like I'm learning concepts from each of these fields that I could very easily apply to the other field. This is crazy, dude. This is blowing my mind. This is holy shit. Anyways, okay. We shouldn't get too distracted with this. So we're gonna go back to Fyrox. Now, okay. Um, we are not gonna finish reading this thing because if I continue reading this, I'm gonna read this off stream. So Gemini, I'm just gonna scroll through this to show you guys exactly, like, give you a high level kind of thing, um, of what the conversation was like. I said, okay, is ECS really the best way to go about things when it comes to game dev? And then the reply was, because I know the answer is no, it's not always the best way. The quote unquote best way really depends on what exactly you are trying to do, right? And it also depends on the scale of your project, because not every project is going to be like a massive indie or a massive AAA project. Some projects are small and simple enough that you are able to get away with very simple architectures and still have very complex, sophisticated systems implemented even within that simple architecture. If that makes sense. So the response was, that's the $1 million question in game architecture. The short answer is no. ECS is not always the best, but it's an incredibly powerful and effective solution. There's actually, I just remembered this. There was one more question that I'd asked down here. Yeah. Um, so there was that whole explanation over here about you know, the pros and the cons, how ECS works and what problems ECS solves and stuff like that. Okay, great. Then I asked a question, or well, I said, would you mind giving me a rundown on a bunch of different approaches, explaining them and perhaps also giving me their pros and cons, and when I might prefer to use each? Also, as a small side question, Bevy heavily, holy shit, Bevy heavily focuses on ECS for a lot of stuff. What if you didn't want to use ECS when coding in Bevy? I'm definitely using Nano, but I was curious. Okay, so then the response was, excellent question. This gets to the heart of game architecture. Let's do a deep dive into the most common patterns. A key thing to remember is that these are not mutually exclusive. Most large games are a hybrid. I actually completely forgot, like, that's even a possibility. It just never occurred to me that, yeah, it might be like a mix of multiple architectures. You may not necessarily always be following one thing. Okay, a key thing to remember is that these are not mutually exclusive. Most large games are a hybrid using the right tool for the right job. For example, you might use a state machine to manage the overall game flow, and within the playing state, you use an ECS to manage all the characters and items. That's interesting. Okay, all right. A tour of game development architectures. So we have the simple game loop. Then we have the object-oriented approach. I'm not going to read out the entire thing because I'm going to read it myself later on after I'm done with the stream, because yesterday after I had this conversation, I kind of went to sleep. It was the end of my day, so I was like, yeah, I'll wake up later on and do this. But also another reason, there was, okay, yeah, I haven't even gotten to like the best part of like why I had a day yesterday after stream. Um, I'll get to that. So then there's ECS after OOP, and then there's state machine. Right. Then side question. What if you didn't want to use ECS in Bevy? The answer is you would be fighting the engine every step of the way. Bevy is not just an engine that has an ECS, it's an engine that is an ECS. Everything from rendering to input to UI is built on top of it. A 3D model in the world is an entity with transform, mesh, and material components. Processing a key inserts a keyboard input event, which is handled by systems. UI buttons are entities with button style and interaction components. You could theoretically ignore all of this. You could create a single resource, Bevy's version of a global singleton, to hold your entire game model, and then have a single system that just runs model.update every frame. However, by doing this, you would effectively be disabling the entire engine. You would lose all the performance benefits. You wouldn't be able to use any community plugins as they are all built as systems and components. You'd be using Bevy as nothing more than a window opener and input provider, a task for which a much lighter library like Winit would be better suited. The short answer, if you don't want to use ECS, you don't want to use Bevy. For a non-ECS approach in Rust, Nano is a fantastic choice, as are other libraries like MacroQuad or a more object-oriented engine, or the more object-oriented engine Fyrox. This is where all of a sudden I remembered, holy shit, Fyrox. I was like, okay, this name seems familiar. I need to go look this up because I've heard this name before. And then when I looked it up, I was like, oh damn, I completely forgot about this thing. I forgot that this thing exists. And then I started looking into it. Now, before all of this happened, something else happened. Yesterday, after the stream, I decided to, look further into Bevy and go through the tutorial where they're teaching about creating the app itself, and then adding plugins and more stuff. So I was in the app section where they ask you to create like a very basic empty Bevy project. Creating an empty Bevy project is basically you just create a Rust project, and then you add Bevy as a dependency. That's it. That's your empty Bevy project. However, the thing is, you need to be careful when you're trying to build this project, or even trying to open this project in an IDE like NeoVim in my case, because when you try to build the project, the Rust compiler, or the multiple instances of the Rust compiler that get fired up, they're going to take like a good, not even like hundreds of MBs. They'll take good like 1+ GB. I actually had that happen, and it came super close to crashing my system, or freezing, not crashing. Came super close to freezing one of my more limited, one of my resource constrained systems. This was like a 6 GB system that I was doing it on, and fortunately I managed to free up enough memory in time to let the thing continue. And then of course there's the fact that the build itself is happening. That's going to take some time. So in the meantime, I have to worry about like, oh, is the processor gonna like heat up? Fortunately, I had BTOP running the entire time, and I was looking at the temperature constantly. Okay, fine. I then the next challenge. Actually, wait, I just remembered. No, I just remember what I'm telling you was like from earlier, from like way back when. Yesterday, I tried doing it on my other system. I tried running Bevy because I remembered the nightmare that I had with Bevy, like previously, trying to open up a Bevy project previously. And so I didn't open it up on my 6 GB laptop. This was like back then that I'm remembering that I accidentally said right now. What happened yesterday was with my desktop, which has 12 GB of RAM. And the first issue was building. I went through the build process. Pretty much what I was talking about. It fills up the RAM. You'll have multiple instances of the Rust compiler that are taking up like GBs in your memory, and because the Rust build tool chain is it's very it's very efficient with your processor cores and stuff. So like it does do multi-threading in whatever way that it's set up to do. It does do multi-threading. So it is absolutely using multiple cores, all all of the available cores on your CPU. You're going to be seeing, if you have a process monitor open, you're going to be seeing like 100% usage in it. So then you shouldn't be surprised if the temperature starts if the temperature starts to rise up gradually because the processor is being used at 100%. Now that's fine. Okay, I ran through the build process, right? That's fine. I then opened up the project. Keep in mind, this is a blank project. It's an empty project that only has Bevy as a dependency. Bevy is not a small dependency. It's a big dependency. It's the entire engine. Okay. I opened up the project in NeoVim, and in order to provide the IntelliSense features and basically doing like linting work, doing linting and basic like language server things, the Rust analyzer is running, right? I think what does hold on, I need to, because Clippy is involved in this. I don't remember exactly what Clippy is doing. I wanna just look that up so I can tell you guys. Okay, Clippy and Rust Analyzer serve distinct but complementary roles in Rust development. Clippy is a linter that provides suggestions for code optimization. Okay, Clippy is what's providing the IntelliSense stuff. My bad. The Rust Analyzer does the other stuff, like detecting errors and giving you warnings and stuff like that. Um, Clippy's lints are categorized by severity and type, correctness, style, performance. Um, Identifying common mistakes and encouraging idiomatic Rust. It operates on additional. Okay. Rust Analyzer gives you code completion, go to definition, inline error. You know what? Okay. These are like details that I don't really need to focus on right now. Rust Analyzer and Clippy. I don't know. I don't remember why I was talking about this. Rust Analyzer. The Rust Analyzer, um, I believe because it loads up a bunch of these libraries, so it can do whatever it needs to do. It starts to take up a bunch of memory. The crazy thing is, I wasn't expecting the Rust Analyzer to take up to 5.7 GB of memory. Again, keep in mind, empty project. Cargo, not cargo, Bevy. Bevy is the only dependency in the project, but Bevy is not a small dependency, right? It's the entire game engine. The Rust Analyzer was taking 5.7 GB of memory. Fortunately, this was a 12 GB system. The thing is, already like 3 to 4 GB of that was just not available. So on this 12 GB system, I already only had like 8 to 9 GB available, right? 5.7 GB, let's call it 6 GB, but like, okay, 5.7 GB was already taken up by the Rust Analyzer. So then I went through the simple process of I went through the simple example of writing an app, which is basically just like in the main function it tells you to write app new um, app new something more. I don't remember what the next one was, but yeah, it's one very simple line of code, and then at the top there's a include or a use statement that you have to add. Very simple, right? And then you run it. I ran it, and then it started doing the compilation and linking. So one of the reasons why I ran the build process earlier was so that it wouldn't run the entire, like it wouldn't try to recompile the entire thing when I tried to do cargo run. but it did have to still do the linking process to produce the final binary. And here's the crazy thing. During this process, first the Rust compiler ended up taking up 1 to 2 GB, right? Once that finished, the linker started doing its thing, and then the linker started taking up 2 to 3 GB. Now, keep in mind, 5.7 GB already used up by the Rust analyzer, right? The system is already using 3 to 4 GB, right? And that leaves us with only like 2 or 3 GB remaining, which the linker just took that up as well. I ended up in like a super weird situation trying to get this thing to compile. Um, the machine on which I have my tmux server running, where there's multiple tmux sessions, sessions that allow me to have this kind of a thing where I'm able to access all of this, which is running on a different machine, but I'm able to access it from a different machine. So that's why I'm able to like stream it as well. Yeah, all of this kind of stuff. It's all hosted on that 12 GB machine, and all of that just froze. Literally, all of it just froze. I thought I managed to close NeoVim in time to close the Rust analyzer so that a good chunk of memory would get freed, so the linker could finish its thing, and then I could open up the project again. But apparently, I wasn't fast enough. The whole thing ended up getting stuck. The machine itself froze. It became unresponsive. It didn't restart though. It just became unresponsive. And I remembered from the past that, hey, just because it's unresponsive visually doesn't mean that you won't you can't, get the machine to do stuff in other ways. So after just waiting for it for a while, initially this didn't occur to me. Initially, I didn't get this idea that, okay, maybe I could try this specific thing. I decided to just wait. I was like, okay, let's just wait for some time, let the machine do its thing. Eventually, it's gonna like the 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 machine filled up so much, the memory filled up so much that the system had to move um, a bunch of the stuff to swap memory, which is basically stuff that's on the hard drive, and that is like super slow. That is incredibly slow, but that's the best that the system can do to provide itself with a little more RAM. It's just that it's going to be slower. The operations are going to be so much slower because there's a massive difference between um, loading something and reading and writing to and from RAM constantly, and reading and writing to and from um, the hard drive, somewhere on the hard drive. Anyways, I just left the system alone. Fortunately, my other system, my 6 GB laptop, that was still functional. So I was like, okay, let me just continue. And in the meantime, I was doing research on other stuff, and that's so I was having this whole conversation, and around that time is when I think I started having the like. Actually, it was shortly after that I think that the whole like Fyrox thing came up. But okay, um, what was I saying? Yeah. So eventually, it occurred to me, hey, this machine that's currently frozen, the 12 GB machine on which I have my tmux server running, I also have an SSH server or an SSH service running on there, meaning I can SSH into this machine. That's how I use tmux from other machines on this machine through SSH. So I was like, okay, all of the other SSH sessions that I did have open, they're all stuck. They're all frozen. What if I could open up a new tab on one of my other machines and try to connect to this frozen machine, but not connect, just literally send one command. The command was going to be to kill the process that's running the Rust analyzer, and then kill the process that's running the Rust compiler. Or I think it was LD, so the linker. One of these two. The second one was either the Rust compiler or the linker. I believe it was the linker. Anyways, I fortunately had BTOP open on that 12 GB machine before the thing went unresponsive. So I was able to see the PID of the process ID of um, both of the processes that I wanted to kill. It was just a matter of getting the machine to respond. So I tried from both of my other laptops. I tried to send the command, and on these machines, on this machine, I don't use. There's a key based approach. I forgot what that approach is called, but the idea there is that you set up these keys so that um, I forgot what the keys were called, but like the idea is that you set up a key based mechanism where where authentication becomes automatic because the system has established that yes, this machine that's trying to connect to that machine is the actual authorized machine. It's not some malicious actor or anything. That's the whole idea of setting up this key based approach for each of these machines. I didn't want to do that because well, I didn't want to do that. So I decided to go with the password based approach. It works for me for now because these are all my machines. Like it's all my local network. I'm the only one using all the machines on this network. So I didn't really see the need for the key based approach. The key based approach would have been the only thing that it would do for me is prevent, not prevent. Well, okay, there's a security aspect to it, right? But another thing, something that the key based approach really helps with is it's a little more convenient because it's not going to constantly ask you for the password. That's it. And I'm okay with having to enter the password. So I was like, okay. Anyways, so I was like, yeah, let me try to send the command from through SSH. And that's when I discovered that yeah, the system is actually like properly unresponsive. It hasn't crashed though, and I'm so glad that the system did not crash. It it struggled, but it tried to get through it somehow. um I put in the command, SSH so and so user at so and so IP address, and then I entered the command to send a kill signal to so and so process ID. And I did that on one machine, and then on another machine I did another similar thing, but I gave a different process ID. So one was for the Rust analyzer, the other was for the linker, and then I just waited. And dude, believe it or not, it took a good half an hour, I think, before the thing became responsive. And finally, I managed to crash both of those processes, and I saved the system. But that did that did solidify something for me, and that is that I cannot use Bevy. I cannot use Bevy on my best machine. So I probably shouldn't bother learning Bevy at this point until I manage to reduce the memory usage of it. I created a question here, and I'm waiting for somebody to answer it. I'm hoping somebody answers it at some point. That is here. Yeah, I asked the question in the Bevy in the Bevy repo under discussions. I wasn't sure if I should create an issue out of it or create a discussion out of it. So I created a discussion instead, because an issue would be more like, oh, there's a bug, or there's something that fails or something. My thing was just, hey, the framework and the tools involved are hogging too much memory, and so I'm not able to use it. Is there anything that I can do to reduce this memory usage? So I put it in discussions instead. I'm hoping eventually someone responds, but in the meantime, I cannot do anything with Bevy. Okay, now keeping that in mind, um, I'm happy to say that I found Fyrox and I decided to explore Fyrox. So I'm still going to be doing stuff with Nano. But I'm also going to be doing stuff with Fyrox. And here's the amazing thing, dude. Like, okay, Fyrox mentions that the requirement is only like 512 MB of RAM. That blew my mind. And okay, let me be clear about something. Compiling the Fyrox editor and the Fyrox engine itself, that's still going to take a good couple of GB of your memory, but that but that's during the compilation process. That's something that happens once when, and I had to go through that, which is why I started the stream a little late, because I had to finish the compilation process and um, then start up the editor. But the editor itself, it's maybe a couple hundred MB less, in fact. Maybe it'll increase once I start having more and more things. Once I actually start building a project, then the requirement is going to increase. But for the time being, it's super low. Something I need to look into is how heavy the Rust analyzer is going to get when I try to open a Fyrox project in NeoVim. So far, let me show you guys. Um, I think we are done with this. Yeah, I think we're done with this thing. I don't want to open. Right, so this is our project. Okay, I don't want to open this up right now um, in NeoVim because it starts to there's multiple things here. Hold on. Let me open this up in Yahtzee. So you have multiple Rust projects. I'm guessing this is a workspace, which is interesting. I'm still learning about workspaces. I have a separate what do you call it? A separate conversation happening with Gemini that involves workspaces. Actually, it's all about workspaces. Gemini is going to be teaching me about cargo workspaces, so I can learn the concept of managing multiple projects under one workspace, and also the concept of examples comes under workspaces. Examples is something that I've seen in multiple Rust frameworks and libraries and stuff, which is great because it makes it like this out of the box. You have this functionality for providing examples for any library that you are currently designing. Like that's really think about that for a second. They've thought they've added this design. It feels like a bunch of things that are part of the Rust toolchain and the Rust ecosystem and stuff. A bunch of the practices, a bunch of the features that are part of the various tools involved in the Rust toolchain. A bunch of these things are part of a bunch of these things were made. Let me just say that. I keep trying to say part of, but then I'm talking about two different things. But yeah, okay. A bunch of these things were designed to solve problems that have existed in other languages, if that makes sense. Like out of the box, certain features like this are just they're not, or they weren't. I can't say for sure right now, but they weren't common. They weren't as common in the past. So you would have to come up with your own method for setting up something like, for example, examples. You would have to come up with your own method of doing it, and different people will have different ways of doing that, right? Everyone will have their own convention of how they want to set up examples and what they want to name things, and is every single example a separate Rust project or stuff like that, right? And then you don't have like a standard way of doing it, so not everyone knows how they should go about looking for things. But then here you have examples. Uh, I could show. I don't know if Bevy follows that convention, but like, let me open it. I think Nano follows that convention. Nano actually has a couple of um, similar examples, not just its own examples, but it tried to implement, for the sake of creating examples, they tried to implement creative coding examples from other what do I even call them? From other situations, from other platforms. There was um, a generative art, a generative, like it's not Gen AI. It's art that's generated using mathematical algorithms. So there was an entire book that was teaching you how to do generative art, and of course going into the math algorithms and stuff like that as well. They implemented that in Nano, just to, you know, give you more examples. Let me show you. I don't remember if hold on. Let's where is, so this is Nano Guide. Is there like a running examples? Let's see. There might be a link to the, yeah, here it is. Nano provides three collections of examples. There's examples, generative design, and nature of code. So there's examples. Let me show you examples. Actually, I should look into how they set these up, because I believe you can set up like multiple ways to, because like these, each of these, then they become part of the workspace, and because of that you are able to use a specific naming convention um, to compile them all using cargo run. Right, so this is the examples thing, right? You can run these examples using cargo run example. There's an example flag in cargo, and then you can provide the example name, which would be one of these names. Or is there something within each of these? No, yeah, it's just these. Though, okay, each of these is not a separate project. I feel like that's something I need to explore, because I think they set up their own way. Hold on, draw. Yeah, each of these is not its own project. I feel like I need to look into how you, because there are a couple of other, like Bevy, for example. If you look at Bevy's examples, um, in the examples section, each thing is its own separate project. And I mean, there's pros and cons to that, obviously. But I was wondering if this is a possibility. Turns out it is a possibility. This thing where you like these scripts, it's just the scripts that you're seeing. You're not seeing the entire project itself. But yeah, I guess I'll learn more about this once I go further with the workspaces tutorial. Now, okay, um, what you are seeing on the right side of the screen, or bottom right, center right, that is um, the Fyrox editor. And I'm interested in looking into, oh God, what just happened? Yeah, okay. I'm interested in looking into this this framework and this engine. And something that I found interesting is this thing. As I was going through, I'm glad that they have like a list of the features, so you can like, actually, let me refresh this. Hopefully it's not all expanded. Yeah. So this is the list. You can expand whichever one is relevant to you. Something that I found interesting was where is it? Wait, that's weird. Where was it here? Oh, it was here. Something I found interesting was this thing, multi-mode. They mentioned use the engine either as a framework or as a full-featured game engine. The first option allows you to use the engine in an editor-less mode. It is possible to build your own tooling using this mode. The latter option releases the full power of the engine. I don't know if they meant releases or realizes. Either way, it's yeah, they both make sense. Yeah, the latter option releases the power of the full engine, allowing you to run your game in the editor and use full power of the editor. So I want to explore both of these things because I feel like being able to do this thing in sort of a headless mode, that would be an interesting experience as well. That is if I go further in this. I kind of feel like if I'm gonna be doing game development stuff, I might as well use a game engine framework. I'm still gonna stick with Nano for creative coding stuff. Who knows? Maybe if I like the workflow in Fyrox, which doesn't strictly follow an ECS approach, which I found interesting. Like they have their own approach, which is more of an OOP like approach, but like in a certain different way. Apparently, they're not using inheritance; they're using something called composition, which I haven't fully understood. The actually, okay, let me wait. Let me look that up. Rust inheritance versus composition. Okay, Rust does not have classical inheritance as found in object-oriented languages like Java or C++. Instead, Rust promotes composition and trait-based polymorphism as the primary mechanisms for code reuse and building relationships between types. Okay, inheritance. Okay, all right, fine. Then composition in Rust. Composition involves a has a relationship. Has a. Okay, where a struct contains instances of other structs as fields. Okay, this allows for building complex types by combining simpler independent components. Code reuse is achieved by delegating functionality to the contained components. Example, a car struct might contain an engine struct and a tire struct. Okay, so I'm gonna explore that concept more later on. But yeah, this is something that I found interesting, and we are 1 hour and 15 minutes into the. I had so much to talk about. Holy shit! Though we didn't really end up going too deep into Fyrox, I was just talking about Nano and Bevy the entire time, and my experience with trying to do stuff with Bevy. Like one thing became clear to me that I cannot do stuff with Bevy. That's straight up. I cannot do stuff with Bevy solely because of the amount of memory that all of the tools involved consume. Um, if I'm not able to, if I'm not able to have an empty project, an empty Bevy project open in NeoVim, and at the same time, you know, compile the binary, produce the binary for that bare bones project. If I'm not able to do these simple tasks, then like I don't think I don't think trying to do more complex things in Bevy is really going to work out. I'm constantly going to be in a low memory kind of situation, and I don't really want to do that. So until I find a way to reduce the amount of memory that Bevy takes, I'm going to go with the other tools. And so far, Fyrox, aside from its initial compilation process, because from what I understand, the first time that you run Fyrox, it has to compile the engine and the editor. So that compilation process does take time, and it also takes a couple of GB. Like it's going to take a big amount of memory. Um, but once the compilation is over and the binaries are produced, further from that point, unless you update the engine, I guess, which even if you do update the engine, I don't think you're going to end up having to compile the entire thing. I think because it's modular, so you'll only have to compile like recompile specific things, and you don't have to compile it either. It's like um, Fyrox has like a project manager kind of thing. You open that up, and in that you can create your projects, and then through each of those projects, like you can select a project and click edit, and then that's gonna load up the actual editor itself. So like yeah, Fyrox and the Fyrox editor both need to be they need to be compiled the first time. So that's going to eat up a lot of memory. But once that process is over, um, it's not going to consume memory anymore. Like for example, right now I have the Fyrox editor open, and let me open up my BTOP and check how much memory Fyrox is taking. It's not mentioning. Hold on, let me uh, look at it as a tree-based thing. Why is this not showing me a tree? Oh, okay, that's why. Um, all right, just a second here. Let me look because it has to be open in. It's not open in. No, it's not open in Tmux. It is open in the Kitty terminal. So I need to keep that in mind. Okay, there's Kitty, there's Fyrox, and in Fyrox there's Fyrox Project Manager, and under that there's Cargo. That's about it. So the Fyrox Project Manager is taking 142 MB, and Cargo, I'm not sure what it is. Oh, it's the editor. The editor is running under that. That's taking up around 200 MB. So far, that's about it. There isn't too much memory usage that I need to, be concerned with. And I need to get into the scripting side of Fyrox to see what the memory usage is like there. Because, it shouldn't be that I open up. I did try opening. Okay, here's the thing, right? I um, I tried opening up this workspace, but then because I'm opening up this workspace, so it started loading up all of the other stuff. Um, and like each of these, there's like multiple projects under this workspace. If you look at the terminal file, it mentions their members, editor, executor, and so and so, so and so, so and so. So there's like multiple things under this. That's probably why it started to take up a lot of memory. So what I need to look at is how I'm meant to be. Like, okay, when I create a script for a certain thing, if I create a script to define certain types of behavior, certain types of logic, where exactly is that script going? And if I want to edit that script, then what specific folder am I opening? Um, so far, yeah, because so far I'm not sure where exactly I'm supposed to be going. It could be this, but then this seems more like a library. Um, features default and then dilib engine. Yeah, I'm not sure where exactly I'm supposed to be creating the. What about target? Okay. Um, yeah, I'm not sure where I'm supposed to be creating it, but that's where our learning process comes in. We will learn about Fyrox. Okay, so we can take it from the top. Just a second. All right, so they mentioned something interesting here. Oh, wait. If you want to start using the engine as fast as possible, read this chapter. I initially decided to not do that, but oh, hold on, that's interesting. So they jumped into scripting directly. I like that. Okay, all right, all right. Download the project manager for your OS from the website. Oh, okay, all right. Yeah, I did download that. Project manager is part of the engine. is a part of the engine that allows you to manage multiple projects made with the engine all at once. It allows you to create a new project or import an existing one, run the project or edit it in the editor, upgrade the project to a selected version of the engine, and many more options. If you want to learn more about the project manager, read this chapter. Right, okay, so we do that. Um, all right, this answers my question. The game code goes in here. Under data, we have the data folder where all the assets must be located. Subfolders are allowed. Editor, the editor of your project can be deleted if not needed. Okay. Entry point for PC can be deleted if not needed. Entry point for Android can be deleted if not needed. Then for WASM, actually, okay, if I can delete all of these, if I delete all of these and then open up the project, and I'm curious about this, hold on. Um, Executor is for PC, right? We need that. I don't know what it does. I'm going to have to look into what each of these do. I need to understand the structure of this engine. We don't need Android for now. We don't need WASM for now. What is dilib? Special bridge for native code hot reloading functionality can be deleted if not. I love that they're mentioning that you can delete a bunch of things if you don't need them. Executor Android, executor WASM. We need game. We do need the editor. I need to find out exactly what this is doing. Like what happens if I delete the project? What happens if I delete the editor thing? But okay, so let's delete these and then hold on. Where was that installed? Oh, yeah, let's go to Fyrox projects, proj01, and in here we want to go into game. So let's open that up and see. Actually, I'm curious, what's under cargo Tamil here? Also, there's a lib file. Features, Fyrox default and Fyrox dilib. Oh God, oh, wait, hold on. Right, so now that I've opened this and because this is part of that workspace, yeah, failed to load workspace. It's gonna try and load the entire workspace, I'm guessing. Is it? No, hold on. Is it? That's interesting. I'm not sure if it's, hold on. Is something running right now? I don't think anything is running right now. Root directory, okay. Um, Wait, I need to, I don't see, because usually if the Rust analyzer is running, then it's gonna show up and it's also gonna take up memory. Doesn't seem to be doing that. Okay, so let's open that up. I need to see that message. Notification history. Let's look at that. Right. Rust Analyzer health status error, failed to load workspaces, run so and so for details to configure or disable Rust Analyzer server status notification. Okay, all right. Okay. Um, the thing is, hold on, my machine is taking up a lot of memory. I can't remember what all is open that's taking up so much memory. Okay, we can close that one, and that's about it. There isn't supposed to be too much else taking up memory. Oh, maybe there's an update thing running. Yeah, you know what? We could close this, and then that's gonna give a certain amount of memory. So that gives 6 GB of available memory. Um, I just realized that I wait, no, can are you guys actually able to see it? Yeah, okay, okay, you're able to see it. Okay, so we're gonna open up this entire workspace. Okay, this is the workspace. And now we are gonna see. Hold on, it's still saying that's interesting. That is that is interesting. Why is it saying that? Okay, I need to figure out I need to figure out what the issue is there. Because previously it would start the Rust analyzer. Now it's not starting the Rust analyzer for some reason. I don't think we have IntelliSense. We don't have IntelliSense. Hold on. Let's close this. Close this as well. I'm confused about this. Log file for details. Um, oh, Rust LSP. Log file. Failed to load manifest for workspace members, so and so, so and so, so and so. Okay, where is this saved? Hold on, I need to be able to. Wait, how big is this? Okay, no such file. Failed to read cargo terminal. Oh, I deleted those, but they're still mentioned in the. I think it's because they're still mentioned in the workspace thing. Yeah, I think that's it. So here's what we can do. Okay, we'll get rid of these two. And then we should be good. Cargo workspace reloaded, and now everything is working. Oh God, wait, hold on, back up, back up, back up, back up. Is, um, wait, right, so Rust Analyzer is gonna be taking up some amount of memory now. Let's see though. Let's see after deleting those two, what like how did the situation change. I also need to see if editor needs to be part of this or not. I think the only way I'm gonna figure out if editor needs to be part of this or not is if I after I dive deeper into this engine, because it's very much possible that because like okay, for example, in Unity when you're writing a game, you don't need the editor namespace. Like that's not supposed to be a part of your script. Um, it's only supposed to be a part of editor scripts, and editor scripts are executed differently. In fact, they used to be needed to be put into an editor folder. I don't know if that situation has changed now, but editor scripts are treated differently because they're executed differently. They are never part of um, the final game. They're never part of the runtime itself. So I'm wondering if that's a similar situation here. So if I'm not writing editor tools, maybe I don't need editor related stuff, right? But I'm not sure if that is the case. There's something maybe there's some functionality that the actual editor requires. So I don't want to delete this, though they did mention that you can delete it if you don't need it. Okay, Rust analyzers memory is increasing. It has jumped up to 2.2 GB, 2.5 GB, 2.8 GB, 3.2 GB. Okay, all right. 3.4 GB. It's still going. It's still going. 3.6 GB. There's some compilation happening as oh god, this is gonna freeze. 4.1 GB, 4.3 GB, 4.5 GB, 4.7 GB, 4.9 GB, 5.1 GB, 5.2. We should stop. Close this, close this. We should stop because the entire system is going to freeze. Yep, the system froze. Fortunately, the system that froze is the other um, system, the other, my desktop. So we can continue with this reading while that system recovers. We believe it or not. Let me. I wish I could. I wish I could show it to you guys, but the I'm looking at BTOP right now, the process monitor. It says used 11.3 GB. Just a second. I think OBS. I think maybe OBS also crashed, and a bunch of other things on that system crashed, like the SRS thing that was running. I think that crashed as well. I'm not sure. But yeah, before it froze, before it became unresponsive, it mentioned 11.3 GB of memory is used up. 5.9 GB out of that is used by the Rust analyzer, and an additional 500 MB was being used by the Rust compiler, and that was continuously like it was rising. It was continuing to rise up. Um, and there was only 219 MB available on the system. Hold on just a minute here. Something happened. Oh, holy shit. I panicked for a second. I was like, okay, did this, is the machine restarting? Fortunately, no, it's not restarting. The machine did go into like a different state. Um, I believe it is responsive. Fortunately, I can open up BTOP elsewhere. Oh, you know what? Yeah, we should be fine. We should be fine. We should be fine. Fortunately, Linux has virtual terminals. So if your system is responsive enough, you can, you know, switch to a virtual terminal. I'm just hoping that uh yeah, let's just wait. Let's just wait. No, no, no. We don't need to. No, you know what? We don't need to wait. We can just continue reading this. Your project needs to be compiled from scratch before it can run. It may take some time. Usually it takes up to 10 minutes on a CPU with 4 cores. 8-core CPU will compile the engine in just 5 minutes or so. Okay. Next runs of the editor will only compile your game, which usually takes a few seconds. Anyway, after some time, you should see the editor window. There it is. Okay, adding game logic. Adding game logic. Any object-specific game logic should be added using scripts. A script is a container for data and code that will be executed. Um, hold on. Oh my God. You know what? Yeah, I think we are good here. Sorry, I was just checking on my desktop because the thing hasn't returned back to no. I actually can't remember what the. Hold on. Let me look this up. Because I can't remember what the virtual terminal was for the desktop environment. I think maybe it was F3, but I can't remember. Because on Ubuntu Studio, it's F7. Ubuntu Virtual Terminal. Um, all right, let's try. Give me a second here because I'm yeah, you know what? Let it do its thing. Oh, there it is. F3 doesn't seem to be doing it, but F1 does seem to take us to. I just can't remember which one is. In Ubuntu, there are 6 virtual consoles which can be accessed by pressing Ctrl Alt F1 to F6 and F7 to exit. Desktop environment button. I don't. Um, Specific keyboard shortcuts. Yeah, for me it seems to be F. Hold on. Is Is everything else still running, or did it just... Okay, is the Tmux server still running? The Tmux server is still running, fortunately. Everything on the desktop environment did crash. Yeah, I took a huge gamble by doing what I did. Which is fine. Um, I can restart everything. Although, I mean, there's no point in restarting the thing right now. I will have to restart it later on eventually. Actually, you know what? Yeah, I should restart it because I need to open up my Firefox before I can do anything. So let's first open... Damn, I haven't opened this file manager in a long time. This GUI based file manager. Ever since I started using Yahtzee, I didn't feel the need to, you know, use one of the GUI file managers. Okay, local kitty.app bin um, and kitty. All right, let's launch it here. And in here, there's going to be a bunch of stuff that I need to set up again. Fortunately, I don't have to set up too much here. I do need to... Is SRS still running? Also, if I now switch to this virtual terminal and then come back here... Oh God, I have to log in again. Why is that though? I didn't have to do that previously. Oh, just a second. I have the kitty terminal here and I have the other one here. Oh, yeah, we can move it here. Kitty terminal's opened up. SRS, I believe... Wait, let's create a bunch of new things here. We need btop here, and SRS is not running. Okay. All right. Let's open up Firefox. Right. So, read the respective chapter to learn how to create, edit, and use scripts in your game. Now, we did make that mistake, right, of trying to open up the entire workspace. Why did this crash as well? All right. Fyrox, okay. Game. Right. So we're going to open this up and see how the memory usage is doing. Right. Let's open up. Oh, I think it might be stuck. Maybe not. Maybe. I think so. Wait. Okay. Yeah, let's open that up and let the loading begin. All right, now here, Load that up, and Firefox is back. Now we need to keep an eye on the Rust analyzer and see what all it loads. I also need to look into if there are ways to turn down the amount of memory that each of these applications is allowed to use, because it seems like a similar situation here as well now, where I need to um, try and turn down the amount of memory that's being used. So far, the most tolerable one that I've had was Nano. I was able to set up the application. I was able to run, like compile and run the application. Um, I didn't have any issues. Okay, so this is starting to bring up a bunch of the same stuff that was being brought up before it actually before the Rust analyzer started taking up too much memory. Okay, Rust analyzer's space or memory usage is increasing. I'm keeping an eye on the memory. Okay, while this is happening, we can continue reading this. Installation and project creation is this. Okay, Fyrox is a compiled game engine. This means that your game needs to be compiled to native code before it can be run. This fact requires a specific project structure, which is generated when you're making a new project. This project consists of a few Rust crates, game, editor, executors for each platform. All right. Oh, hold on. Um, the Rust analyzer's usage is increasing, but it doesn't seem to be increasing that badly, as in it's not hogging way too much. So far, we haven't gone into the GBs, but then previously when it happened, it it happened pretty quickly. So I guess I'm gonna have to wait and see. So far, we are in like 200 MB, and we seem to be fine so far. Okay, okay, and there it is. Now it's increasing. 2.5 GB, 2.7, 2.8, 2.9, 3.2, 3.6. Okay, once this goes below 1 GB, I'm gonna close it because I don't want the same situation again. Okay, okay. Now it's 4.4 GB. This is ridiculous, dude. 4.8, 1 point, yeah, okay, close, close. Let's stop. You're joking. I thought I was in normal mode. Okay, all right. Hopefully we saved it in time. I hit space QQ to close NeoVim, and it turns out that I was in insert mode, and so all of a sudden it's typing space QQ, and I'm like, holy shit, you're taking your own time, and I'm like trying to make sure this thing doesn't crash. All right, so this is something that we need to look into because this is clearly um, causing things to become heavy. So I definitely need to look into ways to make the Rust analyzer take. I'm sure someone must have a solution for this. So I'm gonna do some research on this later on. Let's continue reading this out. Every Fyrox game is just a plugin for both the engine and the editor crates. This approach allows the game to run from the editor and enables editing of the game of the game entities from within it, or just run the game without the editor, since not every game needs an editor. This chapter will cover how to install the engine with its platform-specific dependencies and how to use the plugins and the scripting system and how to run the editor. Fyrox needs the following libraries. I don't remember if I've installed these. Okay, this is the project manager that I was talking about previously. Um, so you create your project and you select the project and then click edit. This will bring up, this will open up the editor itself. But if it's the first time running the editor, then it's going to do the whole compile thing. Just a second, then click the plus create button. Oh yeah, that's the button here. Okay. Learn more about the project manager here. I need to learn about these things because I need to see. Okay, to cut down iteration times, you may want to use a powerful yet dangerous tool called native code hot reloading. Okay, we'll look into that later. There are a number of ways in which you can use the engine. For example, if you don't need the editor, just don't use it. You can still compile your game to a desired platform. Even the project manager and the projects it generates aren't mandatory at all. If you want to manually initialize the game engine without all the fancy bells and whistles, read the respective chapter. Keep in mind, however, that this book is written in assumption that you're using the game engine in the recommended way, and not all non-standard usage may what recommended way and all non-standard usage may result in unexpected behavior. The recommended approach does all the heavy lifting for you. You know what? I want to read this. Manual engine initialization. It is possible to initialize the engine manually and have custom game logic loop. It could be done like this. Okay. Keep in mind that this code does not have plugins nor editor support. It's just back it's just bare bones it's just bare bones engine without anything attached to it. If you still need the editor and plugins but don't like the built-in game loop or initialization routines, read the next section. Custom executor. The recommended way of using the engine is to generate a project that has an editor and a bunch of platform-dependent executor crates. If the built-in executor do not have features you need or have some issues you know how to fix, you can create custom executor. All you need to do is copy the built-in one. Okay. Um, and modify as you like. Then you need to replace all usages of built-in one. Hold on, just a second. Right, okay. Okay. So what was I? Where was I? Then you need to replace all usages of the built-in one with your custom one, and that's pretty much it. Now you have full control in engine initialization and game loop. Okay, this is about network. Right. So we have hit a tiny bit of a roadblock here. I still want to learn about this engine, so I still very much want to try my best to make this work. I need to find ways to like reduce the memory usage and stop stuff like the Rust analyzer and the Rust compiler and all from just hogging all of the memory. But other than that, I'm still very much interested in this game engine. I do want to explore this. I don't know to what extent I'm going to be able to use it, but I do want to explore it more. As any other software, Fyrox has its own system requirements that will provide the best user experience. Um, GPU, any relatively modern GPU with OpenGL so and so support. Do not try to run the editor on virtual machines. Pretty much all of them have rudimentary support for graphics APIs. Okay. If the editor fails to start, then it's most likely your video card does not support OpenGL so and so. Okay. It needs at least a dual core CPU. It needs 1 GB of. This is all for the editor, and that's fine. But then what about the Rust analyzer? Yeah, dude, I feel like I need to do more research. Um, I need to do more research on this. And something else I need to look into is what if I go with the no editor approach? The thing is, the editor itself is not that heavy. It's at most like maybe 300 MB. It's the rest of the stuff that really, really eats up memory. And to be fair, I could free up some memory because currently on this machine, I have um, 7.3 GB free and 4.2 GB being used. So if I get rid of, maybe even 2 GB extra from that 4.2 GB, that could be used in, the that could help with the Rust analyzer and whatever else is going to be used. But yeah, um, I need to I need to look into this. I need to look into this. I don't know to what extent I'm going to be able to use it. I really do hope I will be able to use it. So far, it's all coming back to Nano. I do want to continue exploring this, dude. I'm very much interested in this engine because there's like a bunch of stuff that's provided for you already. Um, but yeah, yeah. So, okay, give me a second here. Um, okay, so there's somebody here. Right. This person has mentioned their mic will be off during work sessions, but we can chat in the break. Feel free to let me know what you're working on in chat. Okay, all right. So this person is called Will is working. Um, yeah, we're gonna go. They're studying for something. I think they have exams. Last day of prep before first exam. Final prep with a post grad student. Yes. So we're gonna go to this person's stream and hang out there. So after this, I need to do some research because I really want to be able to explore Fyrox. But I guess I'll find out if I am actually able to use Fyrox at all or not, or if I am actually able to use Fyrox for game development or not. Of course, I could just go back to doing stuff in Nano. I don't mind that at all. But yeah, that's gonna be it for today's stream. Um, Once again, I'm loving the this streak that we have going on. Um, so far, we've been streaming more and more often. Also, yesterday I got the 2025 Twitch recap, and that was interesting to see. It was interesting to see the number of hours that I've been watched and the number of days that I've streamed. Hopefully, the next year, as in this coming year, is gonna involve a lot more streaming. But yeah, dude, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.